All right, welcome. It is December 1st, and if you're watching this and it is not December 1st, you're behind. I didn't have any questions yesterday, which is probably a good thing. That means we understood the material. And so, again, today you're supposed to take notes first. So there's definitions and theorems you're supposed to write down in your notes. That way, when I get to see you guys again, if I do, I will be able to give you a grade on your notes. And if I don't get to see you again, I'm just going to pick a random note section, and that's what your note grade is going to be based on. So make sure you're getting them down. And we will have a test over this. Probably Monday, we're going to have some kind of test on this. So just be prepared. Of course, all this work is due Sunday, so you'll be ready for your Monday test. We'll see. I might try to push it earlier, but just keep following this and you will know exactly when the test is. All right, like I said, there's no questions. Make sure you're keeping up with the work. If you're behind, if you're sick, you need to let me know so I can change things. All right, so if you're haven't done your notes, stop here. Go take your notes real quick so we can talk about the words after you've read them. Okay, now we're back. I have a few new coins just to keep things fun. I have a Filipino peso here from 1972. It's not very new. And then I have it looks like a 50 yen piece from Japan. So we're just going to add that to today, and we'll add some more just to make things a little exciting. Of course, we're dealing with circles, and so might as well look at some of my old coins that I found from time to time. Okay, so I'm going to move these out of the way because I have a nice, beautiful circle here. And that's what we're really all about. So I'm going to clear off this stuff. There we go. And we will continue working with this circle. So we're dealing with arcs today. Central angle. And so we're just going to go ahead and draw things in here. So I'm going to draw my center here. We're going to call this circle C. I'm going to draw a nice little arc here. All right, so our central angle is of a circle is when the vertex is in the center of the circle. So right here, and we'll do it just kind of like in your book. So the central angle would be angle ACB, or just angle angle C. Okay, so I'm going to put an extra point here, just so you know how to write things. So that's our central angle right here. So now we're going to do our minor arc. Okay, minor arcs are going to be smaller. And so I'm just going to do this as my minor arc here. And it's a smaller arc, so I'm going to call it AB. And I'm going to put a little arc symbol. Okay. I'm going to bust out my second. This is going to be my major arc. Okay. And so remember, when we name shapes, we do it by tracing. So my major arc, let's go over here. Major arc is going to be ADB. Okay, so ADB. So the major arc is going to be the bigger arc. Minor arc is going to be the shortest distance between the two. But ADB. So that's how you do the two different arcs there. And of course, a semicircle is easy to know. It is a semicircle is a major arc. I'm sorry, a semicircle is an arc with endpoints that are the endpoints of a diameter. So basically half a circle. All right, measuring a minor arc. That's what we need to be able to do. Okay, so here's how it works here. And I'm going to get another circle out. And we will measure a minor arc. And you'll see what I mean. So let me go ahead and... All right, let's get this going. just have some different sized circles. All right, that's basically in the center. It's supposed to be in the center anyways. So I'm going to call this, let's call this about 80, it's about 45 degrees really. Yeah. It doesn't matter. Let's call it 45 degrees. It's more than 45, it's almost 90, but we'll call it 45 degrees for the sake of this. And so we will go ahead and see the arc, the measure of the arc. Let's call this x, y, and we'll call this z. So we would say something like the measure of x, y. Well, the central angle is 45. The arc is also going to be 45. Okay? So central angle, arc is 45. Major arc. Okay, so the major arc, I need another letter here. We're going to call this K. So this is the minor arc here. Major arc. So we're going to do the measure of the major arc. And what we're going to do, and I bet you a lot of you know this already, so the measure of the major arc is going to be x, k, y. And it is going to equal 360 minus the minor arc. Okay, so that means that the measure of x, k, y is going to equal 315 degrees. Okay, so that's that concept. Now let's go to our postulates here. The arc addition postulate, and we'll move on down the road. I think we got room right here. The arc addition postulate basically states kind of like the angle addition postulate that we did earlier and the segment addition postulate. This circle is going to be interesting. If you got two arcs here, okay, and I'm going to label the central angle, so this maybe, let's call this 30 degrees. Let's call this about 110 degrees. Okay, remember that the central angles also equal the arc. And the arc addition postulate basically says I can add these two arcs together. Okay, so I'll call this A, B, C, D. So if I do it like this, this means just A, C, plus C, D is going to equal A, D. And they're all minor arcs, so I don't have to have that third letter. And so that would just be 30 plus 110 equals 140. All right, that's that theorem explained. Moving on down the road, more circles. All right, congruent circle theorem. Not a lot to say about this. Circles are congruent if and only if they have the same radius. Okay, so that's all that is. So if circles are congruent, their radii are congruent. Okay, congruent central angle theorem. Let's go ahead and draw this one out. I haven't used this guy yet. He's a little small. Okay, so basically this looks a lot like vertical angles to me. We're going to put an X in a circle, and that's how it works. So if we were to do the proof, it actually is, if we do the congruent, Just make sure you're caught up. That's 10.4 theorem. So the two minor arcs are congruent if and only if the corresponding central angles are congruent. Remember, if and only if means it works both ways. So if this is equal to this, which it is because of vertical angles, that means that this would be equal to this. And vice versa. If this arc is equal to this arc, those two are also equal. All right, the last theorem, 10.5. And this is important. We had a whole chapter over similarity. We're not going to deal with a lot of similarity with circles, but all circles are similar. Which is good because it's going to be tough to do side angle side or something like that when you have no angles or sides. So all circles are similar. And you can't see that, but now you can. Okay. Let's make sure I didn't leave out a letter. All right, good, good, good. Now let's look at our work here. It's not too bad, but I want to make sure you can do it. Of course, there are videos on the big ideas, but I wanted to go over your basics so you have all the information you need to do this kind of stuff. Excuse me. I'm going to just do the hard ones here, not overdo it. I think you could do, well, first problem you're going to be faced with, let's just make sure you can do it all so no one gets confused. All right, it's going to have basically a red arc and a blue arc. It's going to be 135, A, C, B, D. And it's going to want name the red minor arc. And in your book, this is the red minor arc right here. And so name the red minor arc. It's going to be, well, not do it in blue. AB. Does order matter? Nope. It could be BA. In your book, I don't know what they're going to do. So be careful, and if you don't get it right, just switch the order. It might be able to do both. Let me know in comments if you can switch the order in your assignment, so I just know. All right, and then it says do your blue major arc. And I did that right. The blue major arc would be and so then I need to find the measure of both. Okay. So the measure of the minor arc is easy, 135. The measure of the major arc is easy. And I'll let you go ahead and figure that one out. And we'll move on. Okay. So we're going to do a lot of things on measuring, finding major arcs, minor arcs, or semicircles. I'm not going to cover a lot. Find the measure of each arc. Okay. I think the hardest thing that we're going to get down to is going to be where we're going to start having, and this is going to be difficult to draw, so I'll just show it to you so I can kind of explain what's going on. And I can get close, maybe. All right, you're going to get something like this. And we're going to focus. There we go. A recent survey asked high school students their favorite type of music. The results are shown in the circle graph. Find each indicated arc measurement. Okay. Well, this one's not super hard. MAE. So that means A all the way to E. All I'm going to do is add up all those different degrees. Okay. But wait, what do we think all these degrees add up to? Do we think they add up to 360? Well, they should, because they're degrees. So now I'm going to go to the next problem. These aren't in degrees. Let me pull out a little bit. These are in percent. And so this one is going to be one you're going to have to do. The circle graph shows the percentage of students enrolled in fall sports at high school. It is possible to find the measure of each minor arc. If so, find the measure of the arc for each category shown. If not, explain why it's not possible. Well, I'm going to say it's possible. Okay, and I'm going to show you how to convert from percent to degrees. Okay, so I'm going to move the book. Or I'm just going to show you how to do the converting from percent to degrees. Okay. Well, that didn't work out well. You have to pull this back so we have room to do this stuff. Okay, we have two circles here. And I'm just going to do this as an example. It might not be the one. Here we go. All right. So we're just going to do this. I'm just going to, let's going to call this, we're going to call this one 15%. And I'm going to want to find the degrees measurement. Well, we know that the whole circle is going to be 100%. And that represents 15%. And we know that these circles are going to equal each other because they are going to be equal circles with the same radius. And so I don't know what the degrees is of this, so I'm going to put an X. But I do know that the whole circle is 360. And so I see it's blurry. So when we get back to non-blurry, we'll talk again. So this arc is 15%. I don't know what this is. Okay? And so central angle, whatever. So 15% over 100%. I don't know what the degrees is over 360 degrees. Okay? All you got to do now is cross multiply. Okay? And so we're going to end up getting 100x equals 15 times 360. And that's going to be 540. 5,400, I mean. And so then we get x is going to equal x is going to equal 54 degrees. Do we see how we did that? So that's also going to be the arc measurement that we need as well. And so that's how you can do that problem. Okay, I'm just going to kind of let you go on this one. And until next time, until tomorrow, good luck. And if you got questions, remember, email me today and I will put it in tomorrow's video. All right, bye.